Hi guys, and welcome back to Max Electronics. A while back I did a video on the fire alarm controller that was notifying you verbally, and it had lights, and that's the controller right there. If you haven't seen that video, you can click the link right here and watch it. In this video we will be updating that and making it a bit different. The other fire controller had LEDs on the panel and a mute button, and that was it. So if you wanted to see, say, which fire alarm, unless you heard it on the speakers where it was, you'd have to come to the controller and look at the panel which LED was lit up. So I thought I'll upgrade it and make it a bit different. So I've made this a design where you have ports with the RS485 that goes to NAC's little displays, and they all interconnected together. So if fire alarm goes off, the display will say where the fire alarm is, and it allows you to mute it from there. To do that, I had to upgrade the main board as well. So there's not much of a difference. So they're pretty much the same. Couple of pins moved around the Arduino. The sound module is now on board, so it doesn't have the module itself soldered on the board. Everything's built in. As you can see, there's a micro SD card slot. It's got auxiliary output for external amp, so you can hook up to a vac alarm external amp, so when the alarm goes off, it'll turn the amp on and send audio through the 3.5 TRS jack. What else? There's also facility for the battery and a fuse for the battery. The RS485 loop is through the RJ45s. The smoke detector inputs are not the screw down connectors like those, they are RJ45 as well. And the auxiliary input outputs, outputs are the same. SD card here. We've got a step up converter, so you can hook up 12 volts battery, 24 volt actually, step down, and it will convert the power. So on the other side, we've got that's the reference to mains, as you can see, so that's going to be all siliconed in, and that's fire alarms themselves, they reference to neutral. That's it here, so that's it. Let's have a look at the schematic. As you can see, there's a lot happening, but it's actually same as the other schematic. I decided to make it in sections, so you've got the amp section here, you've got the connectors, which is, you know, your typical, it still has the LED panel, so you can put LEDs and the key and the mute button. It's got auxiliary output, ISP programmer. That's the processor section. We've got the comms section here, which is the RS485 playback section, micro SD section, auxiliary output section, alarm input section, and power supply section right here. So very simple. Now I'm not going to bore you with assembling this, as you probably already saw in the other video. It's almost identical board. There's a couple of changes, but that's about it. So I'm going to assemble that off camera, and we will come back and assemble the NACs themselves, which is the little switches that's going to go on the wall, and they're going to display where the fire alarm is going off. But before that, let's have a quick word from my sponsor.
This video is sponsored by PCBWay. PCBWay is the leading manufacturer of high-quality multi-layer circuit boards with unbeatable prices. Simply upload the zip file with your project directly to the website, select your preferences, preview your board, select the postage, and get an instant quote. Now you're just one click away from getting your project completed. PCBWay also offers a range of services such as PCB assembly, CNC milling, 3D printing, sheet metal fabrication, and injection molding. Your project will be manufactured by highly trained professionals with a state-of-the-art equipment and delivered to you in no time with safely packed and vacuum-sealed packaging. Prototype the easy way with PCBWay. Quality, integrity, reliability.
Let's start with the schematic for the notification appliance, and it is very simple. So we've got 4 sections here. This section is a power supply, it's just LM7805 with a couple of caps. and the diode. We've got the processor section, which is again very simple. You've got the Atmega 3 to 8P, and it says PB, but it's actually P. Then we've got the CH340C, which is a USB communication with the USB port, which will allow you to change, the names on the display. We've got LEDs, and you may notice they doubled up, so there's 2, 2, and 2. This 2, you actually choose just one. It's going to be either SMD LED or through whole LED, just like you see on the circuit board right here on the other side. Yeah, so you mount the SMD LED just there. Then the other 2 LEDs are for the sides, and that's going to be just on the sides of a display. When the fire alarm goes off, they're going to be blinking red. Then we've got the display section, which is HDSP 2530X, so 32 in my case, which means red OLED display. Oh, sorry, LED display. And I've chosen these displays. They're really old, but I've chosen them because they're very vivid. They LED compared to any OLED or LCD displays that, if you have a smoke, let's say, they're going to be not as visible as this. Then we've got the shift register 74LS595N, but you won't be able to get those. Those are older. LS is a slow speed. You can use as alternative 1074HC 595, and that'll be just fine. It's the same pinout. And we've got our COM section, which is Max 485E chip with a couple of RJ45 jacks. They just loop through. They're going to be supplying power and data, and the termination switch. So if you say this is the last NAC device in a system, we're just going to turn the termination on to terminate the RS485. So let's get assembling. I'm going to get ready and I'll be right back. I've got everything ready, the stencil, the circuit board itself, and the components ready. But before we start, there's a couple of notes here. The actual Atmega chip, because this board doesn't have the ISP facility, it only has the USB. This needs to be loaded with a bootloader before you solder the chip on board. So make sure you put it in a programmer and upload a bootloader for Arduino onto it. This way it'll work with the USB. What's the other notes? That's all my SMD components. It's all ready. That's the HDSP display. Very lovely display, and those dots that you see, that's LEDs, so they're pretty cool. Then what else do I have to know? That's the LEDs. You can see where you can mount the big one, or the SMDs just on the sides. In my case, I'll be putting it through a hole, and all this will go into the wall plate just like this one horizontally. So I'll cut the display and LED holes and drill a hole for the button, and that's just a standard wall plate, Australian wall plate, so that will be perfect for the NAC system. So I'm gonna start assembling it. here it is, complete. Well, no, not really, it's not complete. I still haven't put the screen on because I want to put it through ultrasonic cleaning, and I don't want to put that expensive screen through the ultrasonic bath. But here it is, that's what it's going to look like. So we've got all the ICs and everything we need is in here, and all the RS485 ports and power, and that's what it's going to look like, and just need to touch plate, but that's what it looks like without the screen. So I'm gonna chuck it into ultrasonic cleaning, and I will be right back. The board is now ready, the screen is soldered, so we are going to program it now. Let's plug the board into the USB of your computer. And as you saw, the test 1, 2, 3, that was just a test that I was programming and testing. So when you plug it in, you'll see nothing at all. So let's switch to the screen now. Click Arduino, and this is the file. So there's a few things that you may want to change. Leave the rest as is, but when you see the first pages here, it says self-test, number 1, 2, and so on. This is what's going to be displayed on your display when the fire alarm is activated. So for example, self-test is going to be powered on. We'll see right after we upload. That's the first thing that shows on the screen just after you upload the file, or when you power the device on, to indicate that the power is good and everything is good. Number 1 through to 6 is your fire alarm input. So whatever you name it, when that fire alarm is triggered is what is going to be displayed on your screen. So if we put number 1 as kitchen and number 1 fire alarm goes off, it's going to say kitchen on the screen. Test is going to be displayed when the fire alarm is in the test mode. If you want to test your fire alarms, fire detectors, smoke detectors, heat detectors, and you don't want the main alarm to go off, you put it in the test mode, and all of the NACs will display that with their flashing lights, and you can test your alarms without setting off the main fire alarm. You can change that as well. So they all fit 8 letters, so you can put anything here as long as it's 8 letters. Then this one, evac now, is what is the main event. So when the fire alarm times out in 60 seconds and you haven't muted it, or it's still triggering the fire alarm, it will go into main event, and this is what is going to be displayed on the screen. So let's upload it. So before we do, make sure everything is selected correctly. You will need to download a mini core library from the Arduino. Select at Mega 328, external clock at 16 megahertz, BOD at 4.3 volts, EEPROM retained, LTO disabled, variant 328P/328PA, bootloader yes. So make sure you actually load the bootloader onto the chip before you solder it on, because otherwise you will not be able to use USB. You can do that by using a little programmer, or you can just solder the wires to the ISP pins and just program it that way. And select your COM port. In my case it's 9, in yours it may be different. That is it. Now let's click upload, and you will see once it uploads, you will see that it'll say self-test on the screen. Here we go. So that unit is programmed, as you can see, self-test. So I'm going to program another 4 units that I have here, and then we will switch to other camera and assemble it all together and see how it works. Here's the main board assembled. That's you seeing it for the first time. I'll explain in a second. There is 4 NACs. I've got one somewhere else, I can't find one. But you can hook up as many as you want. They all have the same software. They're just like a remote screen and remote controller for a mute. I'll explain all that in a second. So let's check out the beautiful main board that is sponsored by PCBWay. So we've got the speaker outputs right and left. It's got the polarity there. We've got the adjustment for the volume of the speakers. At the moment I got them turned right down. We've got auxiliary output, the SD card slot. This is this auxiliary audio. That's auxiliary relay output driven by optocouplers, so you can get the fire alarms 1, 2, 3, 4, 5, and evac alarms. There's 2 evac alarms, and this is just a common positive, common negative in case you need for your device. We've got 2 fuses here. One is for the audio amplifier, which is this one, and there's 1 fuse for the RS485 because it does transmit power. We've got our Max 485 chip, which is the 485 network. This is the mute and test keys, and this is the LEDs to output fire alarms 1 through to 6, plus it also outputs mute LED, and it outputs also a test LED. What else do we have? That's already set to 16 volts to power the amp. We've got a fuse here for the battery. That's where the battery goes on, and that's 24 volts in. That is it. That's the amp itself. It needs to be attached to the heatsink. It doesn't need to be really. It doesn't get hot at all, but I would still recommend it. And on the other side, we've just got pin outs. So we've got RS485 tells you which pin's which, and we've got our fire alarms in. So 1 through 5 or 1 through 6 is alarms in, and 7 and 8 is neutral, reference to main volts. And you can see I've used a silicon, special PCB silicon, to isolate it, because after that, that's where the optocouplers are. That is it for this one, and we've of course seen those ones. Now let's interconnect them all together. So for that, I'm going to be using a RS485, doesn't matter which one, it's looped. So let's do actually those two here. Now this is our fire alarm input, which is, again, you just can apply anywhere from 3 to 12 volts on the pins. This is the common one. I'll be using a little battery. And that's our inputs right here. So the last two pins is a reference to 240 or negative. Now I'm going to apply 24 volts to this. Battery is not necessary. You can have a battery, but it's good for backup, but I'm not using the battery. Now I do not have LEDs made yet, or the buttons, but we will be able to see that anyway. If we trigger mute, this will light up anyway, or test LED. They're not that important. Let's plug the speaker in as well. Let's apply 24 volts now and see what happens. All the screen should say self-test. Yep. And that's it. Alright, so when we go into test mode, which is, I believe this is a mute. Yeah, that's mute. So nothing happens when you press mute, and this is a test mode. And you can see all of them are just blinking as a test mode. Why did the speaker didn't say anything? Oh yeah, it doesn't say anything, it just goes into test mode, that's right. So now, obviously if I disconnect this, it'll go out of test mode. But let's see what happens when I connect the battery while it's in test mode. I hope you will be able to hear it. I'll turn the speaker towards the mic. We've got brown as a negative. And let's go for test mode again. Should have a jumper somewhere. There it is. So let's go into test mode again. And let's go for the first one, which is, say, that.
This is a fire alarm test. Smoke detector test. Passed.
So when you hear this, that's when you first detector, and you do the second detector.
This is a fire alarm test. Smoke detector test. Passed.
That works as well. So this is a test mode. It shows you all the LEDs are working and the screen is working. So let's remove that jumper. And now let's go into the fire alarm mode. So I'm going to trigger just one of the fire alarms. I'm not sure which pin is that, but we'll see in the screen in a second. And you'll see they will show you what fire alarm went off. And number 3. We'll press mute. And they're all showing that it's been muted, but it still shows number 3. However, if it times out in 1 minute in the mute mode, they will not time out. They'll just stay indefinitely like this until you disconnect, until fire alarm detector is switched off. So, which I'm going to do now, and they will reset. So I'll disconnect the battery, and they will reset. So if I, however, keep triggering for 1 minute, it goes into evac. So let's do that. I'm going to disconnect the speaker because it is little, but it's loud. So speaker's gone. And I'm going to fast forward a little bit so you don't have to wait the whole minute, but you will see what happens. So I'm triggering. Let's go for another one. Let's go for blue one. So this is how they work, and during the standby you can't press, you will see a quick blink if you press the mute button, but it does not do anything at all. So this is it. That's it for this project. I hope you enjoyed this. You're welcome to download all the files from Patreon. You can download the free PCB files, which is a Gobert files from and a part list from YouTube. But if you want the code for it for both fire alarm and for the NACs, you'd have to get it from Patreon. Again, that's your volume adjustment, and that's your SD card. The files, you will put it as 0001 for fire alarm 1 through to 6. 0007 is the test pass, and 0008 is the evac alarm. So that's it. I hope you enjoyed this video. Don't forget to like, share and subscribe. If you want to watch the video about my previous fire alarm version 1, don't forget to click on this link. My name is Max. I will see you next time. Bye.